Okay, so in this question, liquid is poured into a container at a constant rate of 30 cm cube per second and leaks out at a rate which is proportional to the volume of liquid in the container. So the volume water in the container is VCM cube. So straight away we can see that, okay, for dV dt, which is the rate of change of volume of the water, okay, is equals to the amount of water that is poured into the container per second minus the amount of water that is leaked out of the container per second, which is, and this is the amount of water that is leaked out of the container per second, which is proportional to the volume of liquid in the container. So straight away I can, based on this sentence, I can write this differential equation. When the volume reaches 450 cm cube, it decreases at the rate of 30 cm cube per second. That means dV dt, okay, dV dt when V equals to 450, right, when V equals to the rate, which is equals to 30 cm cube per second. Okay, so we are asked to show this. Alright, it's quite a straightforward question once you're able to form this differential equation and this equation. So what we do is just integrate. So integrate this equation. So we have we just bring all the V over to this side. Alright. Notes we can't just take the, in order to do this differential equation, all these methods, right, do not work. So you can't try to do this, which some of students will tend to do this. You realize you can't integrate, right, and you can't bring the 30 over as well. It also not work, or you cannot, and what still is not right, is not correct at all to do this and leave the 30 there, because it is totally algebraically wrong, a mistake. So all these are not correct, they are wrong, right? So this is the correct way of doing. Alright, and when we integrate, okay, see, k is just a constant. Now we are integrating with respect to the variable v, so we just think of k as, this is the k, is the, anyway, is the constant. So to integrate this, we just make use of the fact whenever the top is the derivative of the denominator, when numerator is derivative of the denominator, we will just use the ln of the denominator. Alright, but now the top is not the derivative of the denominator, because the denominator, the derivative should be, when you differentiate the denominator, it should be minus k. So in order to get minus k up there, I divide by minus k outside of the integral. Note, this is not correct. You can't, for if this is a variable, you can't multiply a variable outside to change a variable inside, but for constant you can do that, right? Remember this rule, a fx, right? You can't bring the fx outside of the integral, but you can bring a, which is a constant, outside of the integral, right, if you want to, right? So this is how we change it to the form such that we could, okay, so integrate 1 dt is just t plus c, where c is a constant. So so on the left hand side, we have changed it into such a form such that we can apply this formula here. So it's minus 1 k ln modulus the denominator 30 minus kV equals to T plus C. Alright, and so next step, we'll just multiply the minus K over, so you have ln 30 minus kV equals to minus KT plus KC. Okay, and 30 minus kV equals to E minus KT plus KC. Alright, which is by the exponential rule, this is just E minus KT multiplied by EKC. And since EKC is a constant, it's a constant, right? We just let A equals to EKC, and we just change it to this equation to AE minus KT, and we will be able to find out what is our A. No worries, when we are given information from here, we will be able to find out what is our A. We don't have to leave it in this form, but if you want, we can, but you don't have to, right? So this is simpler to solve. We just have to solve for one variable. So then we solve to know the constant, sorry, not variable, but to solve this constant. So it's given that then, okay, how we have reached this stage where we get 30 minus kV. Okay, but before that, we are asked to show minus 15 dV dt equals to 2V minus 450. So let's see what it means. So how do we show that? Okay, with this I'm doing one more step of doing the integration, but even before it's asked for, but let's go by the question again. So show that minus 15 dV dt equals to 2V minus 450. Let's make use of this fact, right? Because dV dt, when V equals to 450, that means look at the right hand side of the equation. When V equals to 450 K minus, right, 30 equals to dV dt is 30. Alright, so dV dt is 30. So then I know that, okay, that means my K must be equals to, oops, my K is 0. Is that correct? Let me see. V is 450 proportional decreases. I made a mistake here. Right, so dV dt shouldn't be 30, it should be minus 30 because it decreases, right, at a rate of 30 cm cube. So, and in that case, if I made this okay, doesn't affect the rest of this part, but I just, okay, so this one is minus 30 instead of 30, and then so we will have minus 60 over minus 450. That will give me 326, 2 over 15. Okay, equals to 2 over 15. So we will have the equation as 30 minus 2 over 15V okay, equals to dV dt. So we'll just substitute the K back inside here. So dV dt equals to 30 minus, then if I multiply minus 15 throughout, so I get minus 15 dV dt equals to minus 15 times 30 is minus 450. Minus 15 times minus 2 over 15 is 2V. Okay, so I have this 2V here. So from here, if I do the integration, I'll get this as well. So, but since I've already done the integration, I will substitute K directly into here, right, the k from 2 over 15 I'll substitute directly into here, which will work too. So I have 30 minus 2 over 15v, right, equals to a, which is a e minus 2 over 15t. Alright, I'll get this differential equation when I substitute the k inside this equation. So then it decreases. Okay, so then we see this. So when v equals to 1000 and t equals to 0, then this will help us solve for our value of a. So okay, 1000. So 1000 times, so 30 minus 2 over 15 multiplied by 1000 equals to, I'm using value from here, equals to ae, this one power of 0. I'm using this one, substitute here. So e to the power of 0 is 1, so then I get my a. Right, so with this 30 minus 2 divided by 15 multiplied by 1000 equals to, okay, minus 103 and 1/3. Alright, now if I substitute this value back into this equation, back inside this equation, and I will get a value that is 30 minus 2 over 15 v equals to minus 103 and 1/3 e minus 2 over 15 t. And then I will be, so the a here is not the same as the, okay, it happens to be the same. Okay, so then we will just find what is our v in that format. So v, I will multiply everything by 15, right? So this will be simplified to 30 times 15 is, this is 450 minus 2v equals to minus 103 and, okay, clear. So minus 103 and 1/3. Okay, multiply by multiply by 15 minus 1550 e minus 2 over 15t. Okay, so then we will just rearrange this and we will get to this form. Okay, so just a few more steps. I will take everything divided by 2, so this will be 225 plus this divided by 2 will be 775. E minus 2 over 15 t equals to v. So alpha, in other words, then alpha is my minus 2 over 15, beta would be my 225, and my alpha, my a will be 775, right, comparing to this equation. So my alpha equals to minus 2 over 15, right? It's here compared to here, right? Beta equals to 225, and A here compared to here equals to 775, and that's my equation. And then so this is the right, so sketch the graph of V against T. This you can just plot into your graphic calculator and get the graph. Okay, and it should look like this. Wait a minute. Wait a minute if you want to see the graph. Okay. 225 plus 775 exponential minus 2x divided by 15. Alright, and graph it. We expect the y maximum, alright, the maximum would have to be quite large. That's that you have to, I think because of the values are quite large, so it's better to set the values to x minimum if you're using the TI-84 plus graphic calculator. And you could set to x okay, so it would be a graph that is like this. Okay, if you plot in the calculator, it will give you a graph that is in this shape. But how do you, it will approach an asymptote, but what do you know, how do you know what is the asymptote here? Alright, you can substitute t equals to infinity, alright, because this is x-axis is just t and this one is just your v. Alright, so when t approaches infinity, this one will be e to a power of negative infinity, which will give you 0. Right, e to a power of negative infinity is 0, so you'll get 225. So this asymptote is y equals to 225. Right, so that will be the graph. So that means over time, the volume of the water will reach a constant value 225. It started with volume. It started with how much? When the initially it was 1000 cm cube. So actually you don't have to plot the graph that is below t negative, right? Because it doesn't make sense for t to be negative because it's time. So when t equals to 0, you can see that when t equals to 0, it's just 775 plus 225, which is 1000, which agrees with what we have here, right? And over time it actually decreases. Alright, yeah, until it reach the volume of 225. So this will be the graph. So just plotting into the graphic calculator is not enough. You need to be a bit analytical as well to know that time there's no negative part, so you don't draw this part of the graph. You also need to label the initial, like this initial volume of water, 1000 over here, and as the graph approaches this, you have to draw this horizontal asymptote to show that the volume of the water will become a constant at will approach the 225. Okay, and if you don't draw this asymptote, it will appear that the volume of water approaches 0, which is not true. So yeah, that's for this question.